Okay, welcome back to school on Thursday. Mrs. Hunter's not here. Mrs. Jones will guide you through the video. I'm going straight to number 2. An open box is constructed by a 30 by 20 inch piece of aluminum. They want to know the dimensions, so we have to find the maximum volume. So you're going to set up your function. V equals 30, take away the corners, which is minus 2x, the 20 minus 2x, and then multiply by the height of x. Put that in your y equals. So if you go into Desmos, and I'm just going to put this 1 in, y equals, and we got 30 minus 2x, and then we've got the 20 minus 2x, and then we have x. Okay, so we've got our graph. So now go to where it's maximized. So we're going to have to go way up probably to get the maximum. So I'm going to zoom out just to see where my top is close to. And then I'm going to move all the way to the top. Okay, so I've got my point, and I'm going to zoom it back in here so I can see it better. Okay. All right, so I am at 1056, and I'm at 3.9 is my x. So x, and this is my volume. So height is your x, volume is your y. Okay, I'm going to add that to my smart notebook. Okay, so let me go back into there. Now, that's my page that shows where my volume was. Now, so we've got 1056 is the max volume. And we've got now to find the dimensions. Now, how do I find the dimensions? Well, the length is 30 minus 2x. The width is 20 minus 2x. And the height is just x. So we know x was 3.9. Now, if I know x, all I have to do is plug it in here to find my new length and width. Some of y'all want to write 30 and 20 here. It is not still 30. We took away 2 parts of it, 2 x's. So multiply 2 times 3.9 and take it away from 30. Now rounded, I got 22. And for the width, I did the same thing, multiplied, and I got 12. And I used actually 4. So if I rounded and got 4, 12, and 22, if you didn't, you got some points here. Okay, so that is number 2. Did it the same way we did number 1. You have to know how to put it in Desmos and find your max. And remember, that's the max volume is y. X is your height. You plug in x to find the new length and the new width. Okay, so let's do number 3. Okay, my function is going to be, oh, it's already got the v there, sorry. Okay, we're going to do 10 minus 2x, 12 minus 2x times x. Okay, now when I get my answer here, I get 96. I got a height, I rounded to 2. If you did not, and so then when I plugged it in, I got 6 and 8. Okay, it does not matter which one you put where. As long as you use the 10 and the 12, either one of these, because it does not distinguish which one is your length and width, okay? So either one. And if you use the decimals with this, then you would have rounded, I rounded up, so you'd have some decimals here. So that takes care of problems 1, 2, and 3. Now I'm going to go to the other smart notebook. The modeling one. that y'all had. We finished pretty much a lot of y'all got done in class, but I told you to finish the front if you did not. So, okay, we're starting with number 1 here. A metal worker wants to make an open box 30 by 24. Now it says write an expression for the length, width, and height. So L, I'm going to make L my 30. My width is just the 24 minus 2x. And then the height is x. So all they're asking for is an expression for each one of these. So you know that the length, 30 minus 2x, width is 24 minus 2x, and the height is x. Okay, use your expression to write the function. So now you put it all together, because what do? You multiply length times width times height, and that's your whole function. So now you put it together. And now you graph it. You find the max volume on the graph. And you should have got 1417.87 as your max volume. Now, they want to know the max volume, and they wanted to know the side length of the cutout, square. So that's your square, so that's the x. So it was 4.4 inches. This was inches cubed. Okay. Now, you should be able to go on your Desmos, and you should be able to put this function in and find the max volume and your x. So that is number 1, A, B, and C. Okay, now let's go to number 2. Okay, we've got a cardboard sheet, 10 by 6 centimeters. Write the equation first. So V equals 10 minus 2x, 6 minus 2x times x. Practical domain that represents this problem. So I'm going to go graph this one so we can talk about this practical domain. We talked about it in the fence. The regular domain would be negative. The normal domain, you would tell me, is negative infinity to infinity. But this is practical. We can't have negative numbers for length and width and height. So we got to go get the real one, the practical one. All right, so let me go back to Desmos. All right, now I've already got this in, so all I got to do is change my numbers. So I'm going to change it to pen. And what's the other one? 6. Okay, so I got 6. Now, all right, so now I got to go back to home. Okay, now let's look at our practical domain. Now you can see that your graph is positive here. Okay, let me highlight. No, I can't highlight. Okay, let me just mark on it. Okay, so positive, and it's positive. But once it goes here, it goes to negative. This is a positive graph. So from 0 to 3 is going to be positive. Okay, so that is all the x's that make this graph positive. Okay, the volume is positive from 0 to 3. After that, it goes negative, and then it just keeps going forever. So that's not a valid answer, because after you go to 0, you can't go back up to it, okay, after you go negatives. So 0 to 3 would be our practical domain. Let me save this. Okay, so now I'm in here. So 0 to 3. I do parentheses because we're not including 0 and 3. So also you could write it 0 less than x less than 3. So you understand it's everything in between 0 and 3. Okay, now it wants to know dimensions. That means what is my new length? What is my new width? And we know the height is whatever x is. Okay, so we got to get the dimensions. So finding what the maximum volume is gives us that. So I'm going to go back into my Desmos because I've got it there. All right, so now let's zoom out and get to the top of my, okay, and it was real easy this time. So I'm at 32.8 at 1.2, 32.8 and 1.2, okay. So let me go back to my notebook. Okay, so my max is 32.8 and my x 1.2. Okay, now I have x, so all I have to do to find the length and the width is plug it back in. So, length is 10 minus 2 times 1.2. And that gave me 7.6. Okay, so I'm saying my length is 7.6. My width, I'm plugging in 6 minus 2 times 1.2. And I got 3.6. Okay, so there are my dimensions, length, width, and the height. And I have what my max volume is, and it's centimeters cubed, and this would all be centimeters. Okay, that is number 2. A, B, C, and D. All right, let's go to number 3. Open box. Okay, they tell us it can be no more than 5 centimeters in height. They give us the dimensions, but they also tell us what the volume must be. So sometimes you know how much volume you got. And in this case, they did. The capacity of the box has to be 1575. So you've got to use that in your function. So first of all, my volume is going to be 25 minus 2x, 32 minus 2x times x. So I got my function. Now we know the volume is got to be 1575. Okay. So now I'm going to go to Desmos. I got my function. I got what it's supposed to be equal to. So let's go back into Desmos. Let's fix this. Okay, that's going to be 25. All right, and then 32. Okay, so I'm going to go home. And now I'm going to put in my second one. I need it to equal 1575. I don't know if I put y equals in if I have to. So I'm just going to try it without it. I got to go a long ways to 1575. Okay, so it did not put my line in. All right, so let me put y equals here to get my, so I do have to put y equals. So everybody remember that, to get that line there. Okay, so now I got my line, and it's right here. Okay, so I'm at 1575, so I'm going to zoom in to that. Okay, so if you notice, it crosses at 3 places. 3.5, 5.9, and 19.1. My restriction started, in my words, it says no more than 5 centimeters in height. So I can't pick this one, because that's more than 5. This is more than 5, but this fits. So we're going to use 3.5 as our height. Okay? So 3.5 is going to be our height. Hold on. No, wrong one. Here we go. Okay. Because it said no more than 5, so 3.5 is the one that works. Centimeters. And that's all they ask for is what is the side length of the squares, and that's 3.5. Okay. Now, number 4. We got a sheet of cardboard, 3 by 4. So we're going to add, what are the dimensions of the box with the largest volume? Largest volume is the max volume. Okay, so we got 3 by 4. So I've got V equals 3 minus 2x, 4 minus 2x, and x. Put that in Desmos, graph it, find where your max volume is, and I got 3.03 feet. Which gives me x equal to 0.57 feet. I got feet cubed on that, excuse me. That was volume. So my length I got to find So I got 3 minus 2x. So I'm going to plug in 0.57 there for x. And I got my length is 1.86 feet. My width, I'm going to take 4 minus 2x. So I'm going to multiply by 0.57 in there. And I get the width is 2.86. And our height was 0.57 feet. Okay, so length, width, height. Okay, now we're going on the back. Now these are different. We set up the box problem so we can look at anything they throw at us. Antonio's preparing to make an ice sculpture. He has a block of ice, 5 by 3 by 4, that he wants to reduce in size by shaving off the same amount from the length, width, and height. He wants to reduce the volume of the ice block to 24. So we know the volume's got to equal 24, and we know we're taking the same amount off of the ice, okay? So write a polynomial equation to model this. So V equals, now I've got 5, I've got 3, and I've got 4. Now I want to take the same amount off. I'm not taking 2x off this time. I want to take the same amount. So minus x, minus x, minus x. So put that in your calculator, just like we did everything else, Desmos, and get your volume's got to equal 24. So where this equals 24, so let's go put this in Desmos. All right, so I need 5 minus x. Oops, lost my parentheses. 5 minus x. And then I can take away all of that. Lost my x. Struggle is real. Okay, now try again. Now I want to do 3 minus x and 4 minus x. Okay, parentheses. And now go over and back and do a new parentheses and do 4 minus x and do a parentheses on the end. Okay. Alright, so now I got it all. Now I don't want this to be 1575. We want it to equal 24. Okay, so now I go back to home, get my graph back. Okay, graph looks good. Alright, now at 24, so I got to move to get to 20. Okay, so right here's what happens at 24. Okay, so I get 1 and 24, so that rounded nicely. So my answer is, when my volume is 24, my height is 1. Okay? Or how much I'm taking off. I'm shaving off 1 inch of the 1 foot of ice. Okay, so go back to my notebook. Okay. Okay, so we are here. So x equals 1. And that's all I needed. They wanted to know how much should be taken from each dimension. 1 foot. Okay, so that's how you do number 5 and how it's different. Because we didn't take 2x off because we didn't have a box. We're just taking off the same amount off of each dimension of the ice. Okay, last one. Number 6, we got a length of a cargo space in a sport utility vehicle is 4 inches greater than the height. Okay? The width is 16 inches less than twice the height. The cargo space has a total of 55,296 cubic inches. All right, so we got to write a polynomial function based on that. So L equals 4 inches greater than the height. So when you write that, 4 inches greater, so I would add 4 inches to the height. So length equals height plus 4, because it's 4 inches greater than the height. So h plus 4. Okay, now the width. 16 inches less. So whenever I had 16 inches less, I'm going to do minus 16. So I got 16 inches less, so that's my minus 16. Twice the height, so 2h. Okay, so I've got length and width, and we know the height is h. Okay, and we can put an x for each one of these. So my function looks like this. Volume equals h plus 4 times 2h minus 16 times h. Find the dimensions of the cargo space. So we're going to go plug that in Desmos. Okay. H plus 4. So h plus, or x plus 4. Okay. X plus 4. Parentheses. Okay. And then we've got 2x minus 16. Okay. And then we've got just x. Okay. Parentheses x. Okay. Okay. Oh no, I just deleted it. Okay. I know it's got to equal 55, 9, so I need to put that in. So let me go ahead and do that. I just lost my, I love typing on the computer sometimes, on the board. Okay, try that again. So, y equals x plus 4. Okay, 2x minus 16. Okay, and then x. Okay, now maybe that's right. Okay, 55, 296 is like way up there though. So we're going to have to zoom out a long, 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 long way. Okay. Whoa. Okay, so I'm right in here. So I'm going to zoom back in now that I'm at 55. Okay. So 32 is my height when my max volume is 55,296. Now, everybody understand how I found that? I'm putting both of them in my y equals, so I get where it crosses, and I just kept zooming out till I got up there, and then I zoom back in around where I'm at when I get to that point. Okay, so now we've got, I already did that. Okay, sorry, wrong problem. Right back here. Okay, so we have max, the volume they told us was 55,296 cubic inches. And that happens when h equals 32 inches. Okay, they want the dimensions of the cargo space. So height is 32. So now length equals height plus 4. So I'm going to do 32 plus 4 and get 36 for L. Okay. Then we got to get the width. So it's 2 times 32 minus 16. So that gives me 48 for the width. And then my height was 32. So I got all three dimensions, length, width, and height, by plugging back in the h. Okay. That wraps up the 2 sheets you were finishing about the open box problems. If you still need some help with this, there is a video on Canvas of the open box problems. So make sure you go watch that and then continue to work on these. Thanks, and I hope you have a great rest of the day. Bye.